So in question 1, we have a large exercise center which has several thousand members from age 18 to 15. So this is going to be important already. We have several thousand members. So we have a large sample. And we have people in between ages 18 and 55, and we have several thousand also 56 and older. So this is also going to be important. We have a pretty large sample space for this question. The manager is considering offering online fitness classes and wants to determine whether these people are interested in this or not. So we select a random sample of 170 people between 18 and 55 years old and 230 people who are 56 and older. And they're all investigated. And we have found this data. So 51 of the 170 are interested in taking online classes, and 79 of the 230 above 56 are interested. We need to perform this test at a significance level of 0.05 to determine whether there is enough statistical evidence to show an evidence for a difference in the proportion of these people who want to take online classes. So in this groups between 18 and 55 and above 56. And so we need to complete an appropriate interference procedure. So firstly, we can introduce two variables that here we will work with. The first one will be PY, which is going to be the exercise members who are the young people, so in between 18 and 55. And we will have a PO for the older members, so those will be the members that are above 56 years of age. And then we immediately can state our null hypothesis and our alternate hypothesis. So our null what we have to be testing is whether this proportion is going to be the same. There's enough statistical evidence. So the null hypothesis is going to be that these two proportions are in fact equal. So P young is equal to P old. And so logically, the alternate hypothesis is going to be that, well, they're not equal. Just like this. So these are the first couple of things we need to do here. And then we can decide now what kind of test we want to do. And well, we have to see whether these proportions are the same. So a test that can do that is the two-sample z-test. Two-sample z-test. So this is what we're going to use in this question to see whether there's a difference in the proportions of the populations that were questioned. So this is the first part of the question that we kind of have to consider. And then we can go into the calculations of this. So we basically firstly have to determine whether there's like a large enough sample space, like whether we can actually apply a statistical test here. However, since there are several thousand members, we can assume that these proportions are going to be correct here. So what we can say here is that, well, we could say that the observations are independent. Independent because we were sampling from as we saw at the start, several thousand members. So that's going to be fine here. And then what we can calculate firstly here is the value of the proportions. So these we can denote them with like P star young. That is going to be the number of people, so 51 out of the 170, so 0.3 rate, like 30% of the people would like it. And for the older people, this is going to be 79 over 230, which will be 0.3435. So approximately 34% of the people will be fine with this. And then we can calculate a combined proportion, basically a weighted average of these two groups. So P combined we just have to, well, it's a weighted average, and we weight it with the number of people that took place. So what we will do here is do 170 times 0.3, so that's essentially just 51, and then this we have to add the other group, so 230 times 0.3435, which is going to be 79, and then we will divide it by the total number of people asked, so 170 plus 230, which will give us 0.325. And since our sample space is large enough, what we can assume is that these variables here follow a normal distribution. So as we've already discussed before, sample size is large. So what we can assume here, so if the sample size is large, then what we can assume is that if we are sampling this P young minus P old, it's going to be a normal distribution. So this is going to be normal distribution. So what we can do here now is calculate the value of the test statistics. So we're doing the z-test here. So we have to look at what the formula is. So the z-test statistics is just going to be firstly the younger ones, so 0.3 minus the older ones, so the difference of the two proportions. And it will be divided by, and then we have two square roots over here. So the first one is going to be the combined statistic multiplied with 1 minus the combined statistic. And this will be multiplied with the square root of 1 over the first sample, so out of 170, plus 1 over the second sample, so 230. If we do this, we get that the z-score is approximately minus 0.918. And then we need to find the corresponding p-value. So the p-value we can calculate very easily because it's simply going to be 2 times the probability that z is less than minus 0.918, right? And this we can simply look out of the table at the back of the question paper. So this we can calculate, and we multiply by 2. We should get something around 0.359. So now we have calculated our z statistic, and what we can do now is finally answer the question. So this is clearly larger than our significance level, which was 0.05. What we will have to say then is that the null hypothesis is not rejected. And so the results do not provide any significant statistical evidence that these two groups have it doesn't provide any statistical evidence that there's a difference in the preference. So it's not rejected, so we accept the null hypothesis. So what we see is that their preference is the same. So according to the z-test, the preference of these two groups we have broken up into is going to be the same.